Welcome back to our third lesson in our course Advanced Kubernetes Management with Flux. In this lesson, we will learn how to install Helm charts using the Helm controller Flux operator. Just a reminder, this entire course is documented and available online at the academies.com site. I'll place the link in the description. And just to remind how we work with a single repository. We build this repository in every lesson, so the repository link will be in the description as well. The repository has branches for each lesson. Also, we will really appreciate if you start this repository so it will get more traction, more people can open discussions and PR regarding best practices of managing Kubernetes with Flux. Let's recap what we learned in the previous lesson. So in the previous lesson, we talked about a Flux operator called customize controller. And this is probably the most used operator of Flux to change your cluster state. This operator will change the cluster state, and also the Helm controller, which we will talk in this lesson, you will use that as well to change your Kubernetes cluster state. So before we started talking about the customized controller, we learned some basics. So we learned about the customize tool, which basically aggregates some YAMLs and can patch, overlay, can change the values. So we learned about the customize tool, which the customized controller is using a similar pattern to calculate YAML manifests like the customize tool. And then we learned that the customize tool is you point the customize tool to a folder and it looks for a file called customization YAML that instructs the customize tool how to do its work. So we talked about the customization YAML. Then we learned that the customize and the customization YAML can work together to create patches. For example, if you want, for example, to change a certain field in the YAML manifest, you can use patches. We also learned about overlays, which is kind of an inheritance. You can create some like a base folder for common things, common YAML manifest, and then you can override them, patch them, and add additional things. So it's kind of like inheritance in the customized tool. And then we learned about Flux things. So we learned about that Flux added a custom resource called customization, and the customized controller is basically looking at this custom resource. So if we go back to our code, we'll see that in our clusters, we added apps YAML. We added custom resource definition, customization. This is a Flux CRD, a Flux custom resource that instructs the customized controller that it needs to build the apps staging. So what it will do, it will go to the apps staging and it will look for a customization YAML. Or if there is no customization YAML, it will automatically generate it by recursively going inside the folders and calculating all the manifests in those folders. So this is a custom resource that you can use to instruct the customized controller which folder to build. So we added, and also we changed a bit the infrastructure of our repository. So we added an apps folder, and we also added an infrastructure folder, and we will use those folders with the overlay to actually change stuff between clusters. So the staging cluster can use the customization YAML to change the base YAML manifest that are placed in the base. So we played a bit in the repository with the customization custom resource and customization YAML to restructure our repository. So this was the previous lesson where we discussed about the customized controller. So here's the plan for this lesson. In this lesson, we're going to talk about a Flux operator called Helm controller. The Helm controller is used to install Helm charts. So we see we no longer use the Helm CLI command to install Helm charts. Everything has to be the GitOps way. Everything has to be declarative. So we use Flux and we use Flux custom resources to install Helm chart in a declarative way. So we're going to discuss how to install Helm chart in a Flux managed Kubernetes cluster. We're going to discuss about Helm, so we like to talk about the basics before diving into more complex stuff. So we're going to talk about Helm install, adding repo, adding a chart, about OCI registries, OCI artifacts. So we're going to talk about general concepts of Helm, and we're going to discuss also about best practice. We recommend that to use OCI Helm repositories. We're going to talk about custom resources that Flux added for us for installing Helm charts. So Flux added for us a few custom resources to manage our Helm charts. So Helm repository we use to manage our Helm repositories. Helm chart is used to manage our Helm charts, and HelmRelease is used to install Helm charts using the Helm controller. So we're going to talk about those custom resources. And after learning all this, we're going to use something that is probably usable, and you will probably need this in most of your Kubernetes cluster. In most of your Kubernetes cluster, you will need an ingress controller, and in this course, we will work with the nginx ingress controller. So we'll use Helm and all those custom resources for Flux to install nginx ingress controller in our cluster. So as we mentioned in previous lesson, we no longer change the state of our Kubernetes cluster by running kubectl apply, running commands from the command line, and also we are not changing the cluster state using helm install. Instead, what we are doing is we are pushing YAML manifests and let Flux change our cluster state. And this applies to kubectl apply, and also it applies to Helm installation, installing Helm charts. So to install HelmChart, we need to learn about a Flux operator called helm-controller. And if you go to the terminal, you'll see that you can kubectl get pods in the namespace Flux system, and you'll notice that there is a controller there, the Helm controller, which is the Flux operator that will manage our Helm installation. So we'll learn in this lesson how to use this operator to install Helm charts in a best practice, more professional way. So this is the Helm controller, as mentioned, no longer using the Helm command. Instead, we're going to use the Helm controller. Now, if we go to the Flux documentation, and I'll place the link in the description, and you'll see in the toolkit components, the Helm controller, you see a diagram of how the Helm controller is working. And basically the Helm controller and the source controller is working together. The source controller is in charge to subscribe to a Helm repository and grab a certain chart from that Helm repository. That is the job of the source controller. The Helm controller is in charge of installing the Helm chart and create Helm releases. And the notification part you can ignore for now. We'll have a future lesson about a Flux operator, the notification controller, but you can get notified, for example, in Slack when a new version of the chart is released. So it's a pretty cool, but we'll also learn an even better way to manage your Helm versions by creating something called similar to dependent bot, that you get a PR when a new version is out. So we'll use the Flux image automation to manage our Helm version. So the source controller in charge of subscribing to Helm repository, grabbing the chart, and the Helm controller is in charge of installing that chart. On the left side are those Flux custom resources that are in charge to instruct either the source controller to grab a repository or chart, or the HelmRelease to instruct the Helm controller how to install that chart. So this is the diagram of how the Helm controller is working, and we'll use it in this lesson to install the nginx ingress controller. So the way the Helm controller is working with the custom resources called HelmRelease. So we saw in the diagram we have HelmRelease to control the Helm controller, and Helm repository and Helm chart to control the source controller to grab those Helm charts. And it can perform pretty cool features in the Helm controller. For example, it can perform automatic updates to the chart. It can run Helm test. For example, it can dry run your installation before installing, so you can get alerts if your Helm installation is going to fail. And it's going to also check and correct drifting. So the Helm controller will know what it needs to be installed, and it will also inspect in an interval that those resources are kept like the installation, are kept intact, are not drifting. So it's a really better way than to just use the Helm command. Not only is all your Helm installation will be declarative using the Helm release resources, but you have additional good features that Flux will provide you how to manage those Helm charts, and will also give you in this lesson best practices how to work with Flux managing your Helm charts. Before we start diving into the Flux Helm controller and using that Helm controller to manage and install our Helm chart, using in this lesson the Helm controller to install nginx ingress controller, before we do that, let's recap some basic things about Helm. And I imagine everyone has some experience here with, it is an advanced Kubernetes course, so I guess everyone in this course worked a little bit with Helm and know those basic concepts, but perhaps there are things that you didn't know, new things. For example, the OCI Artifacts and OCI Helm Repositories, those are things that are relatively new, the Open Container Initiative, and it is our best practice and recommended to install Helm charts from OCI Helm Repository. So we'll talk about this as well. So let's recap some things about Helm. First of all, Helm, we know it's like a package manager for Kubernetes, so we can use it to install Kubernetes resources. And basically what it does, it packages together Kubernetes manifests and using sort of templating and values, and it packages those manifests together, and then you can install those resources on your Kubernetes cluster using a helm install command. And notice that we emphasize it, and I can't say it enough, if you manage your cluster with Flux, you no longer use the helm install command to change your cluster state. I cannot emphasize this enough. The only thing you might use helm is the helm command is perhaps to use helm create to create a chart, and maybe to dry run something if you want to check the installation. So this is pretty much what you'll do. Same thing with the kubectl, right? We're still using the kubectl, we're just not using the kubectl apply. So same rule for the helm. You can use helm, but not to change your cluster state. So do not use helm install once we use Flux to manage our cluster. And HelmChart always reminds me, HelmChart and HelmRelease always reminds me of object-oriented programming, about class and instances. So HelmChart is like a recipe how to create those Kubernetes resources. And basically a Helm chart is a bunch of templates with blanks that are filled with values. So this is in a short sentence, what is a Helm chart? So it's template with values. And once those templates and values are baked together, it turns to a Kubernetes manifest, and then Helm install will create from the chart. A release will install that Helm chart and create those resources. So a Helm chart is not a Helm release. A Helm chart is simply describe template and values. It doesn't really create those resources. And those values can be usually the values contain defaults where it can, and you can override those defaults when you do Helm install. And from the template and values baked together, you can create a Kubernetes manifest, and then you can install them. So this is a Helm chart, and you can create a Helm chart by running the command helm create my chart. So if I go to our code base, I can run the command helm create my chart. And once I run this command, I'll see a new folder is created, my chart, and this is a basic template for Helm chart. So you see there is a values of the chart, and there is templates of, for example, deployment. And if those values are baked in the deployment, there will be created a deployment YAML file, and you can place if and values and stuff like that. So this is in general Helm chart. Let's delete this. We will in the future. Let's check something in the Flux system in the components. So there is here, you'll find the helm controller. There is a service account for Helm controller, and there is also a deployment for the Flux operator Helm controller. So those are what we saw that were created when we did kubectl get pods from the namespace Flux system. So we see that a Helm controller is a pod that is running in the namespace Flux system, and it's connected to a service account. And what we'll do later in future lesson, we will modify that service account and create a workload identity, and we'll learn how to use this Helm controller with the service account to access our private Helm repository. So we'll use workload identity, and we'll connect to our Helm private repository. We'll do that in a future lesson. So that's just a spoiler on what awaits further in the course. So this is a Helm chart. Now a Helm release is basically installing a Helm chart, grabbing a Helm chart and placing values and creating a release from a Helm chart. So this is a Helm release. When a chart is created, we often want to distribute that chart, create an easy installation, and share that chart among different teams, different clusters. And for this case, we have the Helm repository. The Helm repository allows us to take our chart and store it in a server. This way, there is an easy installation for our chart, and we can distribute it in different teams. So when we use, in the past, when we use a non-standard way before OCI, we can simply take our chart and store it in pretty much every web server. We can store it in GitHub, we can store it in an S3 bucket, but now we have a new standard that started and is starting to raise in popularity, and in this course we recommend using the new standard, the OCI, the Open Container Initiative, and we recommend to use OCI Repository. This means that our Helm charts will be signed, which is more secure. You know exactly what you need to get in your Helm chart. And in this case, if you want to follow this course, follow our best practice, it's best to use OCI Repository. And in this case, we recommend to use the cloud solution. So the cloud solution, GCP, AWS, Azure, has a solution for artifact registry or storing OCI artifacts, and it can pretty much be used for storing images, Docker images, and also store Helm charts. So in this course, we'll use something called OCI Helm Repository to store our Helm charts as well as store our container images. So that is the Helm repository, which is used to store Helm charts and distribute them. Let's talk about the new standard for containers called OCI. OCI stands for Open Container Initiative, and basically defines a set of standards for working with container that include running images, image formats, storage and distribution, and this way it allows not only to use Docker but basically use other platforms as well to run images. And it's established by the leaders of the container industries. Among them are Docker and Kubernetes. And OCI Repository, we said that OCI also specified distribution and storage. So OCI Repository is getting the OCI standard in how you distribute your images. But it not only can be used for images, basically it can be used for any file. So OCI can be used for distribution of OCI artifacts. And OCI artifacts, we'll talk about OCI artifacts soon. OCI artifacts can also include pretty much everything, but we will focus that our images, our container images, and our Helm charts will be OCI artifacts. This way we can store our images and Helm charts in the same repository. We'll create an OCI repository and store images and Helm charts in that repository. And we highly recommend on working with a OCI repository. So I would say the OCI is starting to raise in popularity, and people are starting to store their Helm charts in OCI repository, and we recommend on doing that. In this course, we will work only with OCI repositories. And if there is something we need to install which is not an OCI repository, we will also open a private cloud-based, we'll store it in GCP, our own private OCI repository. So if there is some kind of chart that we want to install, we will transfer it, which that chart is not in an OCI repository, we will transfer it to our OCI repository. So we highly recommend using OCI repository for image installation as well as Helm chart installation. And as we said, OCI repository can store OCI artifacts. So the OCI also specified about storage and distribution of container images. But that storage and distribution of container images can basically be applied to other files as well. So it can be applied to any file. Basically, it means that storage and distribution include signing of artifacts. So you can know that you get for sure what you want to install. What you want to install is signed and more secure, and you get exactly what you expect. And basically, you can do that to any file or group of file, and that includes container images and Helm chart. That means that we can, instead of we worked with Helm repositories in the past, now we can work with a standard OCI repository, and that OCI repository can store our Helm chart as well as our container images. Time to use Flux HelmController to install nginx ingress controller Helm chart. So for this, we'll open the browser and we'll type in Google nginx ingress controller. And we will go to the first link from the official nginx.com site, nginx ingress controller. So let's see the installation, and in the installation, let's follow installing nginx ingress controller and using installation with Helm. So we'll use this guide as our reference, but not exactly use this guide, because this guide is using Helm install. And as we mentioned, we do not use Helm install to change our cluster state. We use Flux. But we do see that in the Helm install, we are subscribing here to our repository. This is the repository. This is the repository until the charts. This is the actual chart. And so we have all the details we need from this article to create the Flux resources to install nginx ingress controller. Let's start by letting Flux monitor the nginx ingress controller repository. So what we're going to do is use one of Flux custom resources called Helm repository. A Helm repository is a way we can instruct the Flux source control operator to subscribe to a Helm repository. And we use this custom resource to add a Helm repository. And as we said, we recommend on working with OCI Helm repository. This way we have a standard for signing the artifact, and we know that we get exactly what we expect. So let's create this Helm repository custom resource. I'll go back to my code. Now I want to add all the nginx related files and installation inside the infrastructure folder. And I want to install the nginx ingress controller for all the clusters. This is an infrastructure that should be in the base. So in the base folder, I'm going to create a new folder called nginx. And here I will place everything related to this nginx installation. Now I want to also create a customization resource, so Flux will install all the resources in the infrastructure. Similar to what we did in the apps, when we told Flux to create a customization to monitor the apps folder, we'll do something similar. So we'll copy the apps file, and I'm going to rename it. I'm going to call it infrastructure. And what I want Flux to do is go create a customization file. I'm going to name this file infrastructure. And I want Flux to monitor the add customization resource and build the resources in the path infrastructure staging. And this means that I want to add in the infrastructure staging, I want to add a customization YAML. And this way I can basically I created an overlay, right? We learned about it in the customization lesson. So in here I want to add a resource to load the base folder. So I'm loading the base folder, and this will allow me to later patch resources for the staging, do a different patching for the infrastructure in staging and in production. So this means in the base folder, I need to add also a customization YAML. And the customization YAML in the base folder will load the nginx folder. And in the nginx folder, I will also add a customization YAML. Now this customization YAML is empty, but we'll add a resource in the nginx for the Helm repository. So let's create a new resource called repository.yaml. And in here, what I'm going to create is something similar to what I have in the slide. I'm going to create a Helm repository. Notice the API version starts with source. This means that the Helm repository is used by the source controller. So let's create Flux Helm repository for installing nginx ingress controller. So it's API version, and API version starts with source, that was right, source toolkit, and it's v1 beta 2 at the moment. And it's a kind of Helm repository, and it will be installed. We'll install it in a namespace for nginx. So we'll create a separate namespace for nginx, and we'll name this, let's name this nginx as well. And also we will specify in the spec, we'll specify the URL of the repository and the type of the repository. So let's add a spec and add URL and add URL and a type. Let's replace the URL with the nginx documentation. So let's go back to the docs and replace it with the URL until charts. Let's also create the namespace for nginx. So I'm going to create another resource called namespace.yaml and create a namespace for nginx. And we are going to create a namespace that is called nginx. Now those two resources that I just added, I need in the customization YAML to include them. So I'll go to the customization YAML inside the nginx folder, and I will add the repository YAML, and I will also add the namespace YAML. Great. And to verify that everything is working, I can run customize build on the infrastructure staging folder. Now it prints the resources. I always run this before pushing my code, then I will see what Flux will create. So Flux will create a namespace nginx, and will create a Helm repository in the namespace nginx with this URL. Now let's add our code and commit our code. Let's say feature added nginx Helm repository, and let's push our code, and let's go and do a Flux reconcile to run it fast. So let's do a Flux reconcile for customization and Flux reconcile for the infrastructure, and see that everything is created properly. So let's do also for infrastructure. Great. Now let's go back to the terminal, and we should see get namespaces, that a new namespace is created for us. That's the nginx here. Great. And we should see that a new Helm repository from the namespace nginx, we should see that the new Helm repository is created as well. Great. So it's created. Now notice that on OCI Helm repository, unlike the non-OCI Helm repository, well, it's more active. The source controller, you'll see a ready and status, but in OCI Helm repository, you won't see the ready and status. It doesn't mean that it's not working. It's actually working. You'll see an error if it's not, but you won't see a ready and a status here. I have in the article the issue and a discussion about this. This is still in debate at the moment, but you won't see a ready and status. But basically, we managed to create our Helm repository. We are now subscribed to a Helm repository that is containing the nginx ingress controller chart. So what we just did is we instructed the source controller to subscribe to a Helm repository. And we did that by creating a Helm repository CRD. We created a Helm repository CRD that instructs the source controller to subscribe to a Helm repository. Now let's tell the source controller to grab a chart from that repository. And we do that with the HelmChart custom resource. This instructs the source controller to grab a chart from the repository we subscribe to. So let's talk about the HelmChart custom resource. So Flux gave us a HelmChart custom resource, and we use it to grab a Helm chart according to a version. So the HelmChart custom resource can have a version, and then it will tell the source control to grab according to the version specified. And it also has an interval, so it will check automatically if a new chart is released according to the version. For example, in the code you see here, we created a Helm chart that grabs the chart called nginx ingress. This is similar to the chart that we have to grab from the nginx ingress controller installation. So you see here in the nginx ingress documentation that we need to install a chart called, this is the end here, nginx ingress. So this is what we're doing here. We're grabbing a chart named nginx ingress. So you have to specify this field. And you also specify, using the source ref, you specify a reference the Helm repository according to the Helm repository custom resource. In our case, a Helm repository called nginx. You specify the Helm repository that you want to grab the chart from. And a version is also an important field. We'll talk about it in the next slide. So let's create a Helm chart. Let's go back to our code and go to the nginx folder. And in this folder, let's create a new YAML file, and we'll call it chart.yaml. Now, I should say that usually you don't create the Helm chart custom resource. Rather, you create it from the HelmRelease custom resource. We'll see an example later on. I think it's a bit more comfortable, but I do want everyone to understand that this is a custom resource on its own, and understand there is a shortcut to create it using another custom resource, but it is important to focus on this custom resource by itself. So let's create a Helm chart, Flux Helm chart custom resource to grab the nginx ingress controller chart. So the API version is v1 beta 2, that's correct, and the kind is a Helm chart, that's also correct, and we need to specify where we want to put this and how we want to name it. So we want to put it in the namespace we created for nginx, so namespace nginx, and we'll name it nginx, and we need to specify specs, and along the specs we need to specify the chart we need to grab. So we want a chart called nginx ingress according to the documentation nginx ingress. We need to specify the version as well. The version is a semantic version. Let's specify 1.2.0, and so let's specify the version that we want to fetch. And this is a really important field. I'll talk about it in a minute, including best practices. I see a lot of mistakes. Mostly those mistakes are because people just omit this field, which is fine. It's an optional field. Technically, it will work, but I'll talk about this in a minute. I do recommend specifying this field. So I'm going to tell him to try to check for a chart. Let's do 1.2.x. Check if a newer chart is available in the patch here, the latest patch of the 1.2 series, and check it after, let's say not 10 minutes, it's a bit short. Let's say check every, we can update every like 5 hours. Okay, and then I'm pointing to the source ref. So this is a required field where we point to the Helm repository that we just created earlier. So I want to grab from the Helm repository name nginx. So did I miss anything? No. Okay, so this is our Helm chart. We created this resource. We want to add this resource in the nginx customization YAML. So in the resources, let's add the chart.yaml. And we can try to push our code and see what happens. Remember, this is not installing the Helm chart yet. We're not installing the Helm chart, we're simply grabbing the chart. Remember the class and instances, we're grabbing the class, we're not creating an instance, class instance analogy. So let's git status, okay, git add -a, git commit -m. We added a new feature of grab the nginx ingress controller chart. And let's push our code. And let's do a Flux reconcile to quickly see the changes for the infrastructure. So if everything went well, and it seems okay, should see in the, we go to the terminal and we should see that kubectl get helm chart -n in the nginx namespace. We should see in Helm chart, and if everything goes well, we should see ready. This is really important. See the ready true, and see that it actually managed to pull something, and it pulled a chart with version 1.2.0. So that's perfect. We managed to grab the chart. So we managed to create a Helm repository and a Helm chart. We managed to subscribe to a Helm repository and grab a chart from that repository. Let's talk about the Helm chart version. I think this is probably the most important thing you can take from this lesson. The best practices regarding the version. This is so important and often might be a cause for confusion among developers, and also bad practices that might lead to crashes. So I pretty think that what we're talking about, the version, is probably the most important thing you can take from this lesson. It's so important that we are going to dedicate 2 lessons about best practices regarding this field. So one lesson in the future, we are going to talk about Flux notification controller, and we will tell Flux to notify us in the Slack channel when a new chart version is released. So this is one thing that we'll learn in the future. Another lesson about the version that we'll have in the future is using Flux image automation to help us manage those Helm version updates. But for now, this is in the future of the course. For now, let's focus on a few important aspects that you need to remember about the version. First, let's talk briefly. So let's go back to our code. We see that I'm going to the HelmChart custom resource that we just created. So basically, the version and interval works together, right? So every 5 hours, Flux will check if, according to the version we specify, Flux will try to grab every 5 hours the latest patch in the 1.2 series. So this will, and if it finds after 5 hours, if it finds a new artifact, a new version is released of the HelmChart, only in the patch, of course. If a new version is released with the minor or major, it won't grab it. But if a new patch is released, then the source controller will grab the new chart, and then the Helm controller will upgrade automatically according to the version specified. So it automatically updates, which is really cool. A cool feature which you had to do manually if you use the Helm command. Now Flux manages those updates automatically. So it's pretty cool, but it also is risky. For example, if you tell Flux to update the major automatically, so Flux will grab the latest. Let's say I'm saying version is this. I want the version to be this. Sorry. Grab the latest. This is pretty much grab the latest. You can also just drop this field. This is the default value. Grab the latest. In this case, Flux will grab the latest, which can also be a major update. So major update might cause your nginx conf to be in a bad format because something is removed. And this might cause you issues. Now, specifically nginx HelmChart has good tests, so it will run in dry run, and then it will tell you. It won't actually crash in this case, but many HelmChart do not have the dry run and testing to alert you before the installation. So it might cause a crash. So this is why this field is super important, and this is why this field also, what I usually do in this field is depending on the chart, I either say to Flux, grab the latest patch, or I say, depending on the Flux nginx controller, I will say the patch. But for other charts, I might say to Flux, you can grab the patch, and also you can grab the minor. I might be fine with it in certain charts, depending on what the chart is doing. But nginx, I would definitely only keep the patch. This is really important to maintain be more conservative regarding the versions here. And if you're not sure, if I'm not sure regarding if it might cause a crash or not, I would only update the patch. So this is usually what I'm doing in the version here. I want to know exactly in my source control when a new HelmChart, new update is released. I want to actually see in Git that this moved from 1 to 2. I want to actually see the commit that it happened. So if it causes a crash, I can actually track it down. If you don't specify the version and grab just the latest, Flux will automatically update. Suddenly you have a crash and you don't really know why. It's harder to debug. And this is from, personally I did this mistake, and now I'm much more cautious about the version here. It takes a long time to debug those kinds of mistakes. And now I'm more cautious about the version, and I specify the version and make sure that Git, those changes in the version are in Git. That doesn't mean I don't update. I do let Flux update also the major at times, but I'm more cautious about this. But we'll talk about the version updates later today. You'll see how we use a convention like dependent bot, similar to inspired by dependent bot, not dependent bot, inspired by dependent bot, to update by using PR. And in the staging cluster, I might automatically push the main and update. You'll see some cool stuff in a few future lessons. So this is regarding the version. So let's go over what what we just said. So every interval, the latest version is grabbed. according to what we specify in the version. The version is semantic versioning. This means major, minor patch. Just a reminder, patch might be bug fixes. Minor might be a new feature that I added. Major can be breaking changes. And you can specify semantic version, meaning in the interval field, in the version field, you can specify semantic versioning range. So I like the X personally, but you can specify the X if you want to grab the latest patch or latest minor. You can use a caret if you want grab. You want minor and patch update. You can use greater. The default, so this is what we talked about. The default is grab the latest. Please don't grab the latest. You have to specify the version. You have to track the updates using your source control. This grabbing the latest is not the GitHub's way. The GitHub's way is being declarative, being specifically mentioning in the YAML file what you did, what update you did, and letting Flux run on autopilot. Grabbing the latest can cause issues, as we discussed, can cause even crashes. So make sure you specify the version, and later in this course we'll talk about cool ways how we update our how we do use Flux to update our Helm charts in a much safer way than just grabbing the latest. So we managed to instruct the source controller to subscribe to our repository using Helm Repository, and instruct the source controller to grab from the repository a Helm chart. Now it's time to tell the Helm controller using HelmRelease custom resource to install that chart and create a release. So let's do that. Let's learn about the HelmRelease custom resource. So Flux created for us an additional resource to install charts called HelmRelease. And what this chart is doing is going to install, upgrade a chart when a new chart artifact is grabbed. This means that the Helm controller is working together with the source controller, as you see in the diagram here as well. So when the source controller is grabbing a new Helm chart, remember we specified a 5-hour interval to check for a new Helm chart, and then the Helm chart is grabbed according to the version that is specified. So every 5 hours, the latest version according to the version field that we specified. In our case, it was grab the latest patch. So the latest version is grabbed, and after a new version is grabbed, HelmRelease will automatically either install if it's the first time or upgrade if it's the second time. So there is an automatic update according to a Helm chart that is grabbed. Every new Helm chart that is grabbed, a new upgrade, the Helm controller will do upgrade. So let's install and upgrade a chart. You often, when you install a chart, you need to specify values if you want to change the default values in the chart. So you need to specify values, and this custom resource is where you do it. You specify in the custom resource the values that you want changed in the chart. And also, usually you create the Helm chart custom resource that we just created, the Helm chart custom resource. Usually you create it from this custom resource. So this custom resource has like a shortcut to create also a Helm chart, which I find very comfortable, since I can see the version and the version of the release in the same resource. So I like that, and we'll do that. We'll remove the chart and create the chart. We will create the Helm chart using this shortcut, and also gonna check drifting. So it accepts an interval, and every time the interval is reached, it will check if the Helm resources have drifted, and if so, it will correct the drifting. And it will also run Helm test. Now this is really handy. So before it will install a Helm chart, it will run test, run dry run. So I remember I often got nginx dry run errors, and I was alerted before the actual installation. So this is really cool. It runs the test before it installs, and often it will alert you about a failed test, and then you'll be notified before the install. So it's really handy and cool. So let's create our Helm release. So here's an example of the HelmRelease custom resource in the namespace nginx, named nginx. You notice that in this custom resource, there is a chart section. So this is a shortcut for creating the Helm chart resource. So instead of creating a separate custom resource of Helm chart, you can just specify it here, and it's quite handy because this way you see the version of the chart in the HelmRelease custom resource. So it's quite handy, and we'll do it as well in a minute. And every 1 hour it's checked for drifting, and you have a release name to specify release. Remember, a chart can be installed multiple times, so you need to name the release. So it's like the class and instance. This is actually the instance, and you can create multiple instances. So the class instance analogy. So let's create this HelmRelease. So I'll go back to the code, and I will create in the nginx folder. By the way, I often create them in the same file, so it's often comfortable for me to create the repository, the chart, the release, the Helm repository, HelmChart, HelmRelease in the same file, because I like to see everything together. In this lesson, I intentionally separated them to focus on each one. So let's create a new file called release YAML, and in this file we are going to create Flux HelmRelease CRD for installing nginx ingress controller HelmChart. So API version is at v2 beta 2. Notice that the other had source here. This has Helm here in the prefix. This means that this resource is for the Helm controller. The other resources that we had, the HelmChart and the Helm repository, are actually for the source controller. And we have the kind as HelmRelease, and we need to name it. We name it nginx, and we need to place it in the namespace we created for the nginx resources. And we're going to add a chart. So let's delete everything here. We are going to add the chart from here. So let's go back to our chart resource. In fact, let's open it side by side. Let's open it here, and here we'll open the chart. So instead of creating a chart.yaml, I'll specify the chart here. So I'll specify the nginx ingress, the version. I'll specify the interval to check every 5 hours. I'll specify the source ref, Helm repository, nginx. So I specify the chart here. So this means that I don't need let's close everything. So I don't need the chart YAML here. Okay, so I'll keep it here, so it will be in the source, so you can notice it in GitHub, and you have this example. But in our customization, I don't really need the chart YAML. I just need the release YAML. Let's place a comment. This example is not really used. We are creating this from the HelmRelease CRD. Great. So let's go back to the release YAML, and let's continue to specify the other fields that we need. So we need to have a release name, and did I mention? And let's also specify an interval. The interval here. Notice that we have now 2 intervals. So the interval here is for drifting. The interval here is for checking a new chart. So it might be a bit confusing. So let's write a comment. Oh, sorry. This is for drifting of the Helm created resources, and this is for checking of a new chart. Great. Now let's push our code, and let's see if Flux is successfully installing this HelmChart. So git add. Let's do a git status first. Okay. So I'll git add, and I'll git commit. Call it feature added HelmRelease for installing the nginx ingress controller chart. And let's push our code, and let's Flux reconcile the infrastructure. Great, and let's go to the terminal, and let's do a watch for kubectl get all in the namespace nginx. So let's see if our chart is installed. We're going to get every resource in the nginx namespace, and hopefully we'll start seeing stuff like the nginx pod and deployment and service, and also the service is of type load balancer, so it's connected to our GCP cloud and it will create a load balancer. So let's give it a second and see if everything is installed. In the meantime, instead of doing this, we can also do kubectl get HelmRelease, see the resource in the namespace nginx. See if this was created successfully. Okay, so we see it's created, it's ready, true. Status Helm install succeeded for release with chart. So let's watch again. Oh, I think another mistake I did was not targeting to a namespace. So let's also have not target namespace nginx. So I'll do a commit and we'll say bug fix, now placing the HelmChart in the right namespace. Let's push our code. Let's do a Flux reconcile. What Flux reconcile is doing is just running the customization, running the customized controller to actually sync what is described in the infrastructure customization. So let's do again, watch kubectl get all -n nginx. And let's hope that this will work. Let's do another kubectl get HelmRelease. See that everything is okay here. Okay, so it looks good. Helm install succeeded for release v1 with chart nginx ingress controller. Great. So let's do the watch again. So for some reason the kubectl get all seemed to be a bit not working, but the code itself is correct. So let's do a kubectl get pods in the namespace nginx and verify that without the get all. Let's see that we get the nginx pod is running. So we see that a new pod is created by installing the HelmChart. A new pod is created in the namespace nginx, which is now running. We can also kubectl get services in the namespace nginx and see the services that were created, and we expect to see it's an ingress controller, so we expect to see a service of type load balancer. You can also we can also check our cloud provider, which is GCP, that indeed a load balancer is created. We're not going to do it now, but you should verify that as well. But we do see that we have an external IP, so it should be fine. So we saw that our Helm was successfully installed. Great. So we managed to use Flux to install HelmChart. So to summarize this lesson, do not use, we cannot emphasize it enough, if you have Flux managing your cluster, you do not use the helm CLI command to change your cluster state. You use the Helm controller to install charts in a declarative way. So use Helm controller to install Helm charts. And we saw a lot of advantages of using Helm controller. So everything is declarative in Git. You have automatic updates, you have drift checking, you have testing. So you have a lot of cool feature in working with Flux instead of installing manually those Helm charts. So the Helm chart works with the source controller together. So we saw in the diagram that the source controller is subscribing to the Helm repository using the Helm repository custom resource, and the source controller is also grabbing the chart using HelmChart custom resource. And the Helm controller is in charge of actually installing that chart. So as we said, source controller is grabbing the Helm repository and chart. Helm controller will install the chart using the HelmRelease custom resource definition. We also touched about best practices. So in this course, we will focus on installing Helm charts from an OCI Helm repository. So every artifact is signed, and every artifact is signed and secure, so you get exactly what you expect. So there is advantage of using OCI Helm repository. There is also an advantage of using OCI Helm repository when we will work with the Flux image automation tools. So we'll do that as well, and the only way we can let Flux manage our Helm versions is by using OCI Helm repository. So it is important that we keep this in a standard, and this is what we'll do throughout this course. And we also talked about HelmChart version. So we talked about do not automatically grab the latest, specify the version, and in future lesson we will talk about how to manage the updates and the version in a professional way. But do not grab the latest because it can cause issue. It's the non-GitOps way, it's non-declarative. You want everything in your Git, including the version updates. And that's it. Thank you for listening. Just a reminder, if you like the content, like and subscribe. Also, everything is available online, so entire step-by-step of everything we did here you have in academies.com. I'll place the link in the description. You can star us in GitHub to show us also your love, and you can also star our course GitHub repository. So everything is pushed to a single GitHub repository. You can start that GitHub repository as well. That's it. Thank you for listening, and I will see you in the next lesson.